Another feature of Datafy is role-based access control, RBAC in short, where we provide easy roles that we can assign to users so that we can define who can do which tasks, which actions on projects and on environments. So here I'm on a project called Sample Spark, and if I go to the users tabs, I can see that there are no users selected yet. So here, because I'm admin, of course, I can do everything, but here I have the list of all the users for my Datafy installation, and if I add a user to the project, I can decide if he's going to be a contributor, which means, as explained here, that he will be able to see the project, he will be able to build it, deploy it, and run it. But if I decide to make that user an admin of the project, on top of that, he will be able to delete the project, to invite other users to contribute on the project. So very simple two roles for projects. And what we have for roles, we also have for environments. So now we can contribute on the project and invite other people, but we still need to be able to deploy it to environments. So for each environment, let's see, for instance, the development environment here. If I go to the users tab, I can see which users can deploy projects to it. So in order to be able to deploy a project to a given environment, you need the combination of the permission for the project to build it and to deploy to the environment. And again, we have two roles, so contributor and admin. Contributor can deploy and also do a promotion. So once you have deployed, let's say, a project to development, you might want to promote it to production. So we have a Datafy promote command for that. As a contributor, you can do that. And an administrator, again, on top of that, can delete an environment. He can invite other users to use that environment, and so on. So this is RBAC. Also, as an admin, global admin of the installation here, you can also see the whole list of your users and assign them to projects and environments in bulk. Everything that exists in the CLI, in the UI also exists in the CLI. So everything that I do here through clicking, I can also do it through CLI commands. Now that we have explained RBAC, we can explain how Datafy can be used to be integrated in your continuous integration / continuous deployment pipeline. Imagine that you have a user that has the permission to deploy to staging, but is forbidden to deploy to the production environment. Now, next to that, you have a dedicated user, let's say, for your Jenkins pipeline. And this one, we granted permission to deploy to both staging and production. The goal is that only the CI pipeline will use that user, and so that regular developers will never be able to deploy to production. In practice, all the pipeline has to do is build the project as we've seen, deploy to staging, perform some tests, figure out if it's okay to deploy to production, and if it's okay, then it will be able to use the promote command that we will show in a moment, where we can take the project as it was deployed to staging, for instance, and deploy it automatically to production in the same version. And so in this case, only the Jenkins user will be able to do that. In practice, the only thing that we need to use on top of configuring the users, as we explained, is the Datafy project and then promote command, which promotes a project from one environment to another. And if we autocomplete here again, we can see all it takes is the from, the name of the source environment, to which is the destination environment. So in this case would be from staging to production. And that's all it takes to integrate Datafy in your CI/CD pipeline. Datafy allows an organization to implement data access control on a project level. Let's see how this would work with an illustration here. The first step lives actually outside of Datafy, and that would be the layer where you define data access in a data governance suite like Colibra, Data Hub, or your in-house custom tool. And this is the layer where we let people see data sets and request access to them for a purpose. Then in the second step here, another tool receives the granted permissions for certain users to access certain datasets. And it would generate, in the case of Amazon, IAM roles. And those IAM roles allow access to those datasets. And they will also include a trust policy with a Kubernetes service account, because that service account, as we will see, will be generated by Datafy later. This tool in step 2 can be built in-house, or this is something that DataMinded can build for you as well. Now we get to the Datafy side of things. So in step 3, we are in a Datafy project. And as we will see in a few seconds, every time we define a task in Airflow, we need to pass an IAM role that will be assumed by that task, so that when it runs as a container on Kubernetes, it will assume that IAM role. And that also means that you can use multiple IAM roles for one project, because your project can be composed of an ingestion task, another one for processing, another one for exporting, and each of those tasks can use different IAM roles. How it works behind the scenes is that Datafy will automatically provision a Kubernetes service account for that project, and it will check if there is a trust policy between each of the IAM roles that are used in the Airflow DAG and the service account. And through annotations, this will make sure that when Datafy actually runs each of those tasks as containers, as pods, they will assume the correct IAM roles that were provisioned at the top of this chain by the custom tool here. So to recap, people are exploring and requesting access to datasets. Automatically, a tool will generate the IAM roles and trust policies. And then everything else is managed by Datafy automatically. The user just says, I want to use that and that IAM role in my project, and Kubernetes, Datafy creates the Kubernetes service accounts and checks the trust policies to actually run them with the right IAM roles. Now let's see how this works in practice with an example. To demonstrate Datafy data access on a project level, we have created here a data access demo environment. And inside of it, we have a single DAG that contains a few tasks. Let's have a look at the graph view. So it's a pipeline with an ingest task, a process task, and an export task. And then just to show that we can do proper isolation in between projects, we also have a task that tries to ingest data from another project using a role from another project. We will look into the code, of course. So I'm going to switch to the editor. Here is the DAG that defines this project. We can see the 4 tasks here. So the ingest task, process, export, and then the ingest other. And the important part to note here is this. You see that we are using AWS roles. Here we're using the ingest role, the process role, and the export role. And I will show you in the AWS console what those roles are. And here for the other project, we are trying to use a role that was defined for another project. Let's have a look at those roles in the AWS console. So first, note that we have created a bucket for this project here, an S3 bucket. And in that bucket, we have 2 subfolders, one for the project that we're working on with data in row, clean, and master. And we also have a folder for the other project to mimic that this would belong to another project and should not be accessed by your current project. Now, if we look at the IAM roles, you can see that we have created roles for the ingest task, for the process task, for the export task, and then the other project has also a role created here. Let's have a look in details at that role. So we can see that role first has some permissions, of course. So what we are doing in this project is that this role can access the bucket we just talked about, and it can only access the role folder in the demo project. So this is just to mimic that this role would be an ingestion role, so it can only read and write to that role folder. And now the important part is the trust relationships, where we can see that what we declare here is that any service account, Kubernetes service account that follows this pattern here will be able to assume this role. So in this case here we see the name of the environment that we're trying to deploy to in Datafy, and here's the name of our project. In practice, what that means is that if we look at our DAG here, this task here, ingest, will be able to assume the ingest role, because Datafy will automatically create a service account that will have a trust relationship with the IAM role. The same goes for process and for export. So in practice, we can test that. For instance, if we do a Datafy project run and we try to run on that environment the ingest task, this should succeed. Again, this should succeed because we're trying to assume a role which has a trust relation to the service account that Datafy will automatically provision. So here in a few seconds, we should see that we are getting the logs of the ingest task. You see, we are successfully, in this case, listing the content of the raw folder, which the ingest task, of course, can access because it was defined like this. Now, if we try to change the code and we go to the ingest job and we, for instance, try to list the clean folder instead of the raw, this should fail now because we will be able to assume the role, but that role does not have permission to read data in that folder in S3. So indeed, here we get an access denied, and that's because we're trying to list objects in a part of the bucket that our role doesn't have access to, the ingest role doesn't have access to. The last thing I wanted to show is why the ingest task that is trying to take a role from another project is failing. And that is because Datafy prevents a certain project, let's say project A, to assume roles from a project B. So we have isolation between projects. And here, this is exactly what's happening. We are inside a project and we're trying to take the role that was created for another project. So this is basically trying to impersonate another project from this project. And this is gonna fail. So if I try to run this task, basically Datafy will never be able to assume this role from this other project. And so it doesn't even try to execute the code. We see here that it is not possible to assume the role. And so this is exactly what we want. We have separation between projects, and we have seen, to recap, we have seen that we are able to use several IAM roles inside of a single project. Each task can use a different IAM role. Each of those roles are actually assumed thanks to trust relationships between a service account and the IAM role. And if you try to impersonate another project's role, this is also forbidden. So this captures the project-based data access pattern in Datafy.